Welcome to Space News from the Electric Universe, brought to you by the Thunderbolts Project at thunderbolts.info. On February 15, 2013, a large meteor exploded violently in the sky over the Urals region of Russia. Thousands of homes and buildings were damaged, and more than 1,400 were injured by the explosion, which produced as much energy as 24 Hiroshima-sized atomic bombs. The object was the largest to strike the Earth in over a century, since the Tunguska meteor of 1908. Astronomers tell us that meteors are electrically neutral rocks that sometimes explode due to heating and pressure in Earth's atmosphere. But when we examine the Russian meteor, does this explanation fit with the facts?
Well, it was big. They say it was the biggest thing to hit the Earth in 100 years. It didn't really hit the surface of the Earth because it exploded high in the atmosphere. And this itself raises an important question because it's not actually understood how all of this happened. Ironically, the event was caught on many cameras because Russian drivers, in order to defend themselves in court or to collect insurance, had installed dashboard cameras. So many were driving eastward in the vicinity of Chelyabinsk, Russia, February 15th, and suddenly they and their cameras had a perfect view of an incredible spectacle as this cosmic intruder lit up the dawn sky.
Based on infrasound data from around the world, NASA scientists now say that the meteorite was more than 1,000 times larger than originally believed. This modified conclusion reveals the difficulty for astronomers in explaining the extraordinary energies of the exploding meteor.
The evolving scientific interpretations during the day are interesting, particularly the interpretations of size based on visual data. Initial estimates coming from the Russian Academy of Sciences implied a small body weighing perhaps 10 tons. But just a bit later in the morning, astonishing infrasound data from stations as far away as Greenland and Africa came in. At the low frequencies of infrasound, well below human hearing, the event was heard around the world. NASA then released new estimates of size, not 10 tons, but 10,000 tons. The implied energies were incomparably greater than the visual trail in the sky had initially suggested. In fact, that trail alone made it look as if the bolide was fully degraded before reaching the ground. Complicating this question of size is the fact that the envisioned 10,000-ton body failed to create any impact site on Earth. But if the picture is left in confusion, that's because no one has addressed the evident electrical component of the event. Infrasound is the efficient vehicle for sound transmission from electrical blasts, such as lightning from the upper atmosphere. It's electrical energy that fills in the missing pieces of the story. Scientists loosely concluded that the rock was perhaps 55 feet in diameter, arriving at 40,000 miles per hour, producing a trail some 125 miles long. A huge explosion high in the atmosphere produced a shock wave injuring 1,400 people, largely from flying glass. That explosion makes this an unprecedented event in modern times. This entire display occurred in just 30 seconds. And it's been assumed that the explosion occurred because of internal heat and pressure. But how likely is it that in just 30 seconds, the center of the rock could be heated to the temperatures required for it to explode? When larger meteorites have landed on the Earth, very quickly they became stone cold due to the freezing internal temperatures. If you're wondering about this, you might try an experiment. Take an acetylene torch to a good-sized rock for 30 seconds. You'll create a surface temperature over 1,600 degrees Celsius, more than 3,000 degrees Fahrenheit. You'll see that the heat from melting rock has not been transferred more than a few inches at most. but somehow, due to energies inside the Russian fireball, it exploded so violently and so completely that only tiny gravelly pieces could be found. And incidentally, it was briefly thought that a 20-foot hole in the ice of a lake west of Chelyabinsk was caused by a residual chunk of the bolide. So divers investigated. They could find nothing. Disintegration began some 30 miles above the Earth. Then in just half a minute, it released the energy of some 20 or more Hiroshima-sized atomic bombs, including a blinding flash that was described by one observer as bright as 10 suns. Onlookers had to turn away from the glare. It's hard to see how the common picture could even work. Heat the leading edge of the rock just to a melting temperature, and every bit of melted rock would continually be blown off the object by the winds at thousands of miles per hour. How could the spectacular blast of light by this object be produced in such a way? The blinding flare-up saturated the cameras, a perfect analogy to the electric glare of an arc furnace or an arc welder. One video in particular requires closer examination because it's suggestive of exploding material much like you see in arc welding, projected in the direction of the object's flight. We can't vouch for the authenticity of this video, nor should we ignore it. We can only hope it will be scrutinized up to the level it deserves. What is certain is that the meteor did explode, and in the manner expected of a charged body disintegrating under electrical stresses. You see this in an exploding capacitor as non-conductive material violently breaks down. That's the electrical interpretation of this Russian meteor explosion. Another example in the electrical viewpoint would be the sudden flaring and disintegration of negatively charged comets, as occurred in the cases of the comet Elenin, comet Holmes, comet Schwarzmann-Bachmann, comet Linear, and others. The demise of the comets occurred not due to warming from the sun, but in response to charged particles from the sun.
Astronomers now suggest that the Russian meteor should serve as a catalyst for developing anti-asteroid and meteor defense systems. But to proponents of the electric universe, the Russian meteor validates the notion that the Earth possesses a natural defense against impacting bodies. Celestial intruders such as asteroids and meteors are more likely to produce catastrophe, not from the kinetic force of impact, but rather from electrical discharge explosions.
Not to be forgotten in this connection is the famous predecessor event, the Tunguska explosion in 1908, when a cometary or asteroidal body exploded above Siberia, leveling 800 square miles of forest, some 80 million trees, breaking windows more than 100 miles away, but leaving no appreciable impact crater. Both the recent event and the Tunguska event remind us of Walt Thornhill's suggestion that the Earth has a natural electrical defense system, one that would cause larger bodies to disintegrate on entering the charged region of Earth's upper atmosphere. This wouldn't eliminate the catastrophic effects, but it would surely displace the most popular image of asteroidal catastrophe on the internet today. So perhaps one fact is more significant than has been acknowledged. Despite hundreds of injuries, not a single individual died in this event. Something far more devastating would surely have occurred if the object had released the energy of its explosive blast by striking the surface of the Earth.
For continuous updates on space news from the electric universe, stay tuned to thunderbolts.info.